Hi, this is Benish and Morgan with Dynamics. First things first, we need to understand what dynamics is. Dynamics is the study of the motion of objects and the forces causing those motions. Also, it involves the study of forces and the torques and their effects on motion. Dynamics also follows Newton's three basic laws of motion. Newton's first law states that an object at rest will remain at rest, and an object in motion will maintain a constant velocity unless acted upon by a net external force. Newton's second law states that the sum of the forces as a vector, also known as the net force, is equal to the mass times the acceleration as a vector. Newton's third law states for every force that object 1 applies on object 2, there is an equal but opposite force that 2 applies on 1, where both forces are vectors. As it is defined, dynamics has to do with torque, which causes angular acceleration of objects. It also has to do with forces. In general, forces are defined as a push or a pull on an object. But there are different types, such as the friction force, which can also be broken down into static friction and kinetic friction. The force of friction is defined as being parallel to the surface. It opposes motion, and the direction of the force of friction is independent of the direction of the force with which it's applied in. Now, that can also be broken down into static friction, which is non-moving or where two surfaces do not slide relative to one another. The other way it can be broken down is into kinetic friction, which is moving friction or where the two surfaces do slide relative to one another. There's also something called a normal force, which is the force caused by two bodies in direct contact that is perpendicular to the plane of the contact. Although definitions are fun, this can all be better explained through example problem number 1. It states you stand on a bathroom scale in an elevator as it makes a trip from the first floor to the 10th floor of a hotel. Your mass is 50 kilograms. When you stand on the scale in the stationary elevator, it reads 490 newtons. What will the scale read? A. Early in the trip, while the elevator's upward acceleration is 1.0 meters per second squared. B. While the elevator moves up at a constant speed of 4 meters per second. And C. When the elevator slows to a stop with a downward acceleration of 1.0 meters per second magnitude. The absolute first step is to draw a sketch with all of your labeled givens and your labeled system. Then you have to move on to a motion diagram and a force diagram. The motion diagram in this case shows that the change of velocity is in the same direction as the motion, which means that the force in that direction, which is the normal force of the scale exerting on you, is greater than the force of Earth pulling down on you. Then, after that, you can use your equation, which is the acceleration is equal to the sum of those forces over your mass. Now that can be broken down into the two forces subtracted from each other. Then, since Fe on y is equal to mass times gravity, you can plug that in. And then rearrange your equation so that the normal force is equal to the acceleration times your mass plus that mass times gravity, which is ultimately equal to 490 newtons. Now that you have your basic equation, you can plug in your quantities that you were given for A, which is your mass of 50 kilograms and your acceleration of 1 meter per second squared, plus that 490 newtons that we found to get your 540 newtons. Then we perform the same steps with B, creating a motion diagram which shows that the change in velocity is constant, which means the forces are equal, which is called translational equilibrium, which is when the net forces of an object is equal to zero. Then, after you realize that, you can plug in your givens into that same equation again, and you end up with 490 newtons. Then we do the same steps with C, where we create our motion diagram, which in this case shows that the change in velocity is against the motion, which means that the sum of the forces is in the downward direction with the force Earth on you. Then you plug your quantities into that same equation and you get 440. Now time to get a little bit more difficult with example problem number 2. It states you pull horizontally on the handle of a lawnmower that is moving across a horizontal grassy surface. The lawnmower's mass is 32 kilograms. You exert a force of magnitude 96 newtons on the mower. The grassy surface exerts an 83 Newton resistive friction-like force on the mower. Earth exerts a downward force on the mower of magnitude 314 newtons, and the grassy surface exerts an upward normal force of magnitude 314 newtons. What is the acceleration of the mower? Of course, we go through the same process. We draw our sketch, we isolate our system, which is the lawnmower, and we put in all of our givens. Then, we have to draw our force diagram, which in this case has the normal force and the force of Earth as equal. So we don't have to really account for them when we put them into our equation. The only ones we worry about are the ones to the right and left. To the right is the force of U on the lawnmower, which is 96 newtons, and the one to the left is the friction force of the grass on the mower, which is 83 newtons. Then you use that same equation of A equals the sum of the forces over M. So that is going to be your force U on mower plus your friction force of grass on mower over your mass. Then, because the friction force is in the negative direction, you must change it to a negative. You must subtract that number. So then you subtract your numbers and you divide, and you end up with 0.40625 newtons per kilogram, which is equal to 0.41 meters per second squared. Don't worry, dynamics doesn't stop there. Now we get to see how angles affect an object in example problem number 3. It states, while mopping the deck, a sailor pushes with a force of 30 newtons down on the handle of his mop at an angle of 45 degrees on the horizontal. If the mop accelerates horizontally at 1.0 meters per second and the coefficient of kinetic friction is 0.1, what is the mass of the mop? Of course, as always, we start with our sketch with all of our givens, and we use our sketch in order to make our force diagram. Our force diagram in this case is a little bit different because we do have to include the fact that the force is applied both on an angle and horizontally for that 45-degree angle to push it along the deck and into it. Using the equation F net equals Fa minus Fk, we can finally state that F net equals mass times acceleration, which is because of the fact that horizontal acceleration of 1.0 meters per second squared is that net acceleration of the mop. So with that, we use ma equals Fa minus the mu of F times Fn because of that static friction and kinetic friction equation that states that the absolute value of F of friction is less than or equal to mu, which is the friction constant, times the absolute value of force normal. Then after you figure out that that's the equation that you have to use, you plug in all your numbers and you plug in all your angles and you rearrange it in order to solve for M. Eventually, after doing all of your algebra magic, you get M equals 9.6 kilograms.
Now that we've covered all of the instances of dynamics, we wish you the best of luck on your AP exams. And remember, always assume a spherical cow!